declare to be array. First you have to give the data type, then array name, okay. Then since there are two different variables to represent, or you can say two different index variables, so we have to use two subscripted variables here. First one, which will take the row size. The second one, which will take the column size. Okay. So for this particular picture, if this is an integer 2D matrix, then it will be declared like this: int a, how many rows? 2 rows. How many columns? 3 columns. So it will be like this. Now the interesting thing is, although I am drawing a picture like this, like a matrix, but the thing is, this is nothing but again converted to 1D array. Although I am drawing a picture like 2D matrix, but ultimately it will be stored in a form of 1D array. How it will be stored? Now there are two different ways we can store it. One is called row major, okay. Another is called column major. Now from the name you can easily understood that row major means this 2D will be converted to in this form. First row, there's a first row. First row, how many elements? 3 elements. Then the second row. Logic clear? Then the second row. So this is the whole 1D representation of this 2D array. And this is called row major. Okay? This is called row major. Now if it is a column major, how will be the picture will be like this. The picture will be like this. It will be stored first the first column, this one, first column, 2 elements. Then the second column, 2 elements. Then the third column, again 2 elements. Okay. So this is the whole array, 1D format. Okay. This is column major. This is row major. In our C language, this row major concept is used. Column major concept is used in MATLAB. In MATLAB, column major option is used. Now, so if it is a row major in C language, then row wise. So this is the first row, then there is a second row. It means this is one array of 2 elements. See, 2 elements. This is first one A of 0, the second one A of 1. Each element of this array again is an element of 3 arrays. Am I clear? So actually A is an array of 2 elements. Each element again an array of 3 elements. So we can say 2D array is array of arrays. Is it clear? So A is an array of 2 elements. This 2 row, 2 elements. This is 0th row. This is 1th row. 0th row, 1th row. Each element again is an element of an array of 3 elements. So this is 0, 1, 2. Again this is 0, 1. So what is the numbering of this one? The numbering of this one, this is A of 0. So this is A of 0. This is A of 1. So what is this? So what is the name of this array? The name of this array is A of 0. So if the name of this array, instead of A of 0, if it is X, then what is the name of this one? This is X of 0. What is the name of this one? This is X of 1. And actually, what is X? X is A of 0. So this is nothing but equivalent to A of 0, 1. Are you getting? How we are getting the different name of the array element. So this is A00, this is A01, this is A02, this is A10, this is A11, this is A12. How I am getting? Because of this. Because of this, we are getting this type of values. Again, suppose this one. Suppose this one. What is the name of this array? The name of this array is A of 1. What is this one in this array? This is one element. So how to write it? It will be written as A of 1. This is the array name for this particular array, and then 1. That's why in case of 2D array, we can definitely say that 2D array is array of arrays. So this is row major implementation. Okay. Now, so if in case of 1D array, array name is the base address, then in 2D array, what is this? In case of 2D array, what will happen? Array name is the base address. This is true, no problem. Zeroth element of the array in a form of 1D, if I write A of 0, then this is what? This is address of first row, or you can say 0th row. Am I clear? If I am writing A of 1, this is address of second row, or you can say first. Is it clear? Now, how to get then element? The element will be get. So if I write 0th, then again something said second element, 0th second element of the array. Try to understand. Then it is value or element itself. Am I clear? Is it clear? Is this thing clear? Try to understand this thing. This is very important. Is it clear? In case of 1D array name is the base address. This will give you the starting location of the address of the array. So if I say A of 0, then in case of 1D array, A of 0 is definitely element. But in case of 2D array name, same, base address, starting address. This one is the starting address. Say starting address is 100. Now if I print the 0th element of the array or 1th element of the array, then it will be printed like this in case of 2D array. Then we will get what? Again we will get address. A of 0, the starting address or first row base address. A of 1, the second row base address. A of 2, third row base address. Next, if I print 0th second element, so I'm increasing the number of element 0th second or first 0th like this, then now you will get the value or definitely some element. So in this way, it is like this. It is like this. This is definitely some value or element. So try to remember this thing. I hope this thing is clear. Why this thing is happening? Because ultimately your array will be converted to 1D array. In C language, it should be in row major format. Okay. And now from this, you can say that there is nothing like array. According to our imagination, 2D array is like this, but this is not the actual picture. The actual picture is this one. The way I am accessing A of 0, A of 1 like this. It looks like a 2D matrix, but there will be no physical structure of this 2D matrix. This is our logical structure. So that's why we can say there is nothing like array. So what is array? Array is the collection of some homogeneous memory element. See here again, there's a collection of 6 homogeneous location. Nothing else. And how to access them? That will be depend. So in case of 2D array, how to access a particular element of the matrix? I will access it. I need 2 variables, one for representing row and another for representing column. So ij, 2 variables are required. And if I say what is the address of this element? So A of ij is nothing but the element itself. It is element. If I want to say what is the address of this element, can anybody tell me what should be the representation? How we can represent this? Please. The same way, just like I have implemented in 1D array. So this is for 1D array. Don't mismatch. This is for 1D array, and the logic is A plus I into size of data type. Correct? Now, if it is like this, then how to represent the address? Please, anyone? Anyone, please? So I can write it like this. Why I can write like this? Because to reach the jth element, first I have to reach the particular row. So this will give the row address, the base address of the row. And then I am moving towards up to G. Now how to represent this address according to this? So the representation of this address is again A plus I into size of what? That is very important. Now, this is what? A of I is what? Anyone, please? What is this A of I? I have already told. Address of the row, address of the row. So how to get the exact address value from this, from the base address? A into A plus I into size of what? Size of row. I need the row size. How many elements in a particular row? Plus j into size of data type. Am I clear? How I am accessing or getting the address in case of 2D array? Is it clear? Please tell me. Suppose for this example, I need the address of this location. So according to the formula, suppose the base address is 100. So according to the formula, 100 plus, what is the name of this one? The name of this one is A of 1, 1. So this is I, this is J, correct? So I is 1. So 1 into size of row. What is the size of row? This is the size of row, number of elements in a row. How many elements? 3 elements. Each element of integer size 2. So what is the size of the row? Size of the row is 6 bytes. If I consider 2 bytes for each integer. So plus j 1 into size of data type. What is the size? 2. So now it becomes 100 plus 6 plus 2. So it becomes 108. See, if this is 100, okay, then this one 102, this one 104, this one 106, this one 108. So I'm getting the value 108. Logic clear? So how we will convert the address? This will be the conversion of the address. Now, if it is a, instead of this, if it is a column measure representation, then this is your home task. If it is a column measure representation, then how to get the value A of ij? What should be the representation with respect to I and j? Address representation. Just try to formulate this. It's very interesting. Okay. So now I hope you have understood the difference between 1D array and 2D array. How, see, this is almost looking like 1D array element, but since it is 2D array, it will give you address. So if there is a printf statement for a 2D array, suppose I have declared a 2D array like this, 2, 3, and there is a printf statement. I am printing say %d, and I'm writing A of 2, sorry, not to suppose A of 0, then definitely remember this will not print any value or element. This is not an element, this will be some address. And since it is a row measure, so this is row address. Which row address? 0th row address. So this is the difference that you have to understand. Okay. So the next thing, how to, again, in case of 1D array, we have initialized our array. Now, if it is 2D array, how to initialize them? How to initialize 2D array? Suppose this is a 2D array. Okay. The initialization of 2D array is like this. Since there are row and column concept, so 2 row will be separated with 2 different curly braces. So in first row, suppose I have 1, 2, 3. Then in the second one, say 5, 8, 9. So this is the representation. Or you can directly write it 1, 2, 3, 4, 5, 8, 9. This also. This also supported in many compilers. Okay. But remember, you same like 1D array, you cannot put more values. You can give less value you can initialize, but you cannot initialize more value. And another interesting thing that is very important, that if it is a 1D array, I have told you that you can blank this only initialization will assign the size. But if it is a 2D array, then remember this thing. If it is a 2D array, then the row size cannot be blank. Remember this thing. Row size cannot be blank. Column size can be blank. Means you can write it like this. Not initializing. According to your size, if you define 2 elements, it will allocate 2. If you define 3 elements, it will allocate 3. According to your size, it will automatically allocate the number of, means size of the column according to your initialized value. But you cannot write it like this. Blank here you are giving 3, this is not allowed. So row size cannot be blank. Column size can be blank in case of 2D array declaration. Okay, so these are few important things that you have to remember. And then finally, how to take input. So since it is 2D array, so we have two different variables. One is for row, another is for column, and you can easily you can see the similarity between the pattern printing and this 2D matrix. So similar as pattern printing, we will use two different loops, one for row, the first one definitely to represent row, the next one to represent column. Okay, so in case of 2D array, you have to take two inputs from the user, that is how many rows and how many columns. So this is how to take input. And how to access the element. You can access the element definitely. You can print the element using this statement, printf %d ampersand I, sorry, a of I g. This way you can, this is for output. And if you want your output same like matrix, one element, two element, then after this scanf and before this, you have to use one printf statement to print the new line. That's all. This is for printing, not for scanning. This is only for printing output of the 2D matrix. Okay. So with this, I am ending today's class. And in next class, I will go for pointer, and then we will solve some interesting problems using array and our previous concept, function, all those things will be used in our next classes. Means after the pointer concept, we will go for some different problems. We'll discuss some different problems. No, not that much theoretical part, the problem related part, because up to this array and pointer, if I am not able to cover up to this, then it is very difficult to solve some problems, some higher level problems. That's why I am going up to this pointer, and then we will definitely do some problems hands-on. Then obviously I will provide you some assignment. Okay. Okay, with this I'm ending to discuss.